This presentation covers using the social media data analysis software Mozdeh for word association mining. This is a simple data mining approach that you can use to extract patterns from your tweets. First of all, we're going to look at word associations identified by a query. And this has two simple stages. Once you've collected your tweets in Mozdeh, then enter your keyword or query or filters or set filters, and then click the Mine Associations for Search and Filters button. And then Mozdeh will produce a list of words that associate with the query and or filters. And what are these words? These are words that occur more often in tweets matching the search and or filters than in tweets not matching it. So they're words that in that sense associate with the query and or filters. Here's an example. Here are some tweets that mention Sharice Davids in the American elections of a few years ago. So if you look at these tweets, you'll see some words recur in the tweets, and these are words that Mozdeh would say associate with Sharice Davids. So if you search for her tweets, you'll find specific words that associate with her, that are more commonly mentioned in tweets mentioning her than in other election-related tweets. And in Mozdeh, entering the query Sharice, she was the only Sharice standing in the elections in a collection of tweets about the elections. And clicking the Mine Associations button gives a list, as you can see on the screen in the middle, a list of words that occur more often than in Sharice tweets than in the rest of the tweets. So if you look at the word native, for example, if we look at the word native, that's in the list, in the middle of the list. In the matches column, it reports 65.2%. What does that mean? It means 65.2% of the tweets mentioning the word Sharice also contain the word native. And the no match column, 2.2%, that means of the other election tweets, only 2.2% of them contained the word native. So there's a very strong association of the word native with Sharice. All the words in this list also have a very strong association with Sharice. For one reason or another, they're far more likely to be used in tweets mentioning Sharice than tweets not mentioning her. So that's what I mean by an association. And just to recall, this list was produced with just 2 button clicks once the data had been collected. So entering the query, okay, not a button click, and then 1 button click, Mine Associations for Search and Filters, and then you get the list. Although it sometimes takes a half a minute or so for Mozdeh to produce the list. Suppose that you're not interested in a query particularly, but you'd like to know which words are used more by one gender than another, or than the other genders. Then in order to do this, you would blank the search, make sure you have a blank search, and then select a gender, male or female normally. If you want to analyze non-binary genders, check the Mozdeh website for that, and then click the Mine Associations for Search and Filters button, and Mozdeh will find words that associate with the selected gender. In other words, it will find words that occur more often in tweets from that gender than in the remaining tweets. Here's an example. Here the female gender has been selected and the Mine Associations button clicked. And if we look at these words, a strange list of words, although I guess it's not strange to see usernames in them. One of them is Congressional. 6.5% of female authored tweets use the word Congressional. 2.6% of the remaining tweets use the word Congressional. So a Congressional, the word associates with female tweet authors. And that's because more females must have commented on congressional districts. I read lots of these tweets and that seemed to be the underlying reasons. Females are more likely to comment on congressional districts and males are more likely to comment on other aspects of the elections. This might make sense to you if you're an expert on American politics. And this is a section of the tweets, just a mini screenshot of the tweets showing that the word congressional usually associates with the word district. A more powerful association for gender, you can do an explicit search for male versus female. In Mozdeh, to look for words that are more used by males than females. The reason why this is more powerful is the previous method that we've used ignores people that Mozdeh can't find a gender for. So if you want to do a more powerful test, ignore the people that Mozdeh can't find a gender for, which is usually about 70%, then you need to go through this procedure. It's a bit of a faff, but it does get you slightly better results. This procedure has 6 steps. First, you create a sub-project, which is a subset of the tweets you've collected, by selecting the male or female gender. So you have to have male or female selected. Then select the Save tab and check the Make Sub-Project option as shown on the screen. Then click Search and enter M or F as the sub-project name. Then change the gender filter to either female or male, and then click the Mine Associations for search and filters. So these extra stages, 1, 2, 3, 4, create a subset of the tweets that ignore the non-gendered tweets and allow you to do a more powerful search mining test. And here's an example. This is from a project, tweets about Weinstein after he was initially found out. And this is without the gender sub-project. So these are words that are more commonly from females than from either males or people that Mozdeh doesn't know the gender for. And then the same process, but after the sub-project has been created to make the results more precise. So many of the words are the same. There's not a huge change, but there is a change. For example, in the original one, without the gender sub-project, disgusting is further down, 2.6% to 1.5%. And here in the gendered sub-project, it's still 2.6% for females, but it's only 1.2% for, in this case, males. So it does make the difference between females and the rest stronger, because it ignores the males and females and non-binary that will be allocated unknown category. So this is the same for males. These are words associated with males about Weinstein, and this is without creating a gender sub-project. And then inside the gender sub-project, you get a slightly different order of words, more swear words when you ignore the people without a gender for some reason, without an assigned gender. So here's a summary of the top words associated with males and females, just to illustrate that we have found differences between males and females in their reactions to the Weinstein on Twitter. The more political terms for males and more direct terms for females. And also thanking people that have shared their stories of part of the Me Too movement. If we want to look at words associating with sentiment, then we blank the search and select either positive or negative sentiment and click the Mine Associations for search and filters button. And this will tell us which words occur more often in tweets with the selected sentiment than in tweets with other sentiments. So it works very similar to the gender option. For example, here I've selected the positive sentiment. So these are words that occur more often in positive tweets about the US elections. And some of the words are sentiment words themselves, like congratulations, good, great, congrats, proud, hope, supreme, amazing, wow. And then progressive is perhaps the first non-sentiment word. And the reason why it's a sentiment word in the list of words that associate with sentiment is because the progressive candidates did well in these elections. So the more positive tweets tended to be more likely to be about progressive candidates. They were congratulated for winning, whereas the non-progressive Democrats were less likely to be congratulated for winning. Another example for sentiment. These are tweets about museums, a collection of tweets about museums. And again, a positive sentiment filter has been selected here. So for the positive sentiment, you can see words like beautiful, enjoyed, inspired, which are the types of words people use when they say good things about museums on Twitter. And then a similar negative sentiment association found words like shame, sad, disappointed. So these are the types of emotions people feel when they haven't enjoyed their visit to a museum. So this information is giving insights into the reasons why people might enjoy or not enjoy a visit to a museum according to their tweets. I'd just like to talk a little bit about the statistical considerations behind these tests. These are important if you want to report them in an academic journal article. Mozdeh includes some advanced statistics to make sure that the results you report are less likely to be misleading. The advanced tests it uses are tests to guard against falsely reporting a word association as significant when it's not significant. So first of all, Mozdeh runs a chi-squared statistical test, which is reported in a choice column below for each word, and it will tell you if a word is a statistically significant association by putting 1, 2 or 3 stars to the right of the chi-squared value. So if there are 1, 2, 3 or 3 stars, then the association is statistically significant. If there are no stars, then it's not statistically significant. And the statistical tests take into account the family-wise error rate, which is a statistical term meaning that the conclusions are protected even though multiple tests are run at the same time. Usually if you run too many statistical tests, you get some false positives inevitably by accident, but this is guarded against that. And if you want to know more details, if you put a mouse hover over the results, then you get a more precise breakdown of exactly what the stars mean and the procedure used to guard against false results, which is the Benjamini-Hochberg procedure. So that's how to do mine associations. I just want to give a little bit of a warning, which is that the mine associations needs a lot of tweets to work well. If you only have a few tweets, 1,000 tweets, they'll tell you nothing really. If you have 10,000 tweets, you can expect to identify obvious patterns, maybe confirm obvious patterns. And if you start to get really lots of tweets, 100,000, then you can expect to find hidden patterns in the data, patterns that you didn't know. And perhaps if you get to 1 million for your topic, you could get deeper insights. So the more data you get, the more insights you can expect. And when you're doing a pilot test, you probably won't get anything interesting from the results just because you don't have enough tweets. You'll be closer to the 1,000 than the 10,000. So you won't have enough tweets to give you proper insight. So that's just a warning. You don't really know what insights you're going to get until you start the full-scale data collection. Okay, how can we analyze the individual terms? I'm going to give a few hints about analysis methods that you can apply to the list of terms that you get from the mine associations button. So to find out why the words are statistically significant, and have an association, then I recommend reading a random sample of matching tweets to work out the context in which the words are used. So for example, we found the word congressional was always used in the context of the phrase congressional district, so that gave it a bit more clarity in terms of its meaning. And we can use this to detect the underlying causes and help us to summarize the relevance of the term. So for individual terms, we can essentially read random samples of tweets. Remember, you can use a random sort filter in Mozdeh to help with that. And this will give us insights into why the difference occurred. For example, if you applied this method to the word leftist in the male-associated tweets for Weinstein, you might draw the conclusions that males are attempting to make political capital from the Weinstein affair. A more detailed method is to follow up the individual terms to find causes as the individual tweets, and then try to identify broad themes for the causes. So this would involve grouping together similar words or words that had similar causes into a theme and obtaining one or more themes to describe the key types of differences in the data. And if you do this, then it's important to repeatedly re-examine themes and repeatedly recheck words to make sure that your conclusions don't vary as you go through the data and are consistent across the data. And then you might report the main categories in your results. So I'm going to give a more detailed presentation on this, which if you apply this method in detail, then it's the word association thematic analysis method from another presentation. Here are some examples. Here we have terms associated with males, male terms more used by males within the theme of science. Here we can see in the right hand column the individual words found by Mozdeh. In the middle column we can see a narrow theme that the words have been grouped into, and on the left hand column they've been grouped into a broad theme. So we started with a huge list, confusing huge list of words, and we've made the list less confusing by finding the key themes in the words, and even less confusing by finding broad themes. So you might be looking at this table and thinking, well, this is really confusing anyway. But the table was obtained by several days of applying the process on the previous slides, a long effort to identify the themes that the words fit into. So that would explain why application and technique are classified as general, for example, which won't be obvious from the table. So a summary of the word association mining methods. First, we automatically identify words associating with either a keyword or query, a sentiment, gender, retweets, or even time intervals. You can find words associating with time intervals. Then you need human analysis to interpret the results, and then this can identify important themes in the data relevant to your research goals. And final reminder, you need lots of tweets to get good results. You can practice on small samples, but the quality of the results is dependent on the volume of the data you cover.